let's get started. We have got two different things I want to get done today. The first one I'm hoping to do quickly, so I'll try not to spend too much time on it. And it's a section 7.6 on using tables. It's homework, and that's the only time you're actually going to get to use it, directly at least. It won't be in the next test and it won't be in the final, but it is a topic that I feel I have to cover. There are going to be some situations in the next, whatever it is, 5 weeks we've got left, where you will end up having an integral that is very difficult to do or impossible to do, but you can use tables to get the result relatively quickly. So to give you an example of what might that might look like, I'm trying to find one at random here. Suppose you got the integral of the square root of 25 plus x squared dx. Suppose you wanted to find that guy. Now, do you recognize its form? Wouldn't that be an x sub? And if you were doing an x sub, you would eventually have to choose. Does anybody know just off the top of their head which x sub would be the one that you could use on that?
Tangent.
Well, it's going to have a 5 in it, right? What else is it going to have? That's not a good sign. I know you have the little cheat sheets, but if you don't have it with you, then you don't know. That's a bit.
Tangent.
Okay, thank you. Yeah, tick a little bit. If it wasn't that one, wouldn't it be secant? And if you did the secant, I guess 2 lines later, you'd know it was the wrong one. Right, now you could do that. I'm not going to, but we could do that. What's the going rate? About 15 minutes to do it, something like that. Take a long time. If you were allowed to, of course, wouldn't it be nicer if you could use someone else who's already done a question like it? And that's what tables really are. Now, the guy that you would actually find would be the guy, if I can get him, is number 21. And he looks like this. So if you're going to use the tables, one of the things you've got to realize is that you don't see that question in the tables. What you see is a general member of the same family. And in that case, you have to recognize that some people get changed. One of the easiest changes isn't the X going to be a U or the U is going to be an X. And the second change is, won't A be 5? And won't the U be an X? So when I look up 21, I get the ridiculous answer, U over 2, the square root of A squared plus U squared, plus A squared over 2, the natural log of U plus the square root of A squared plus U squared. And then you add C, right? That's what this is equal to. And so to be able to use the tables, don't you just go through and every A becomes a 5 and every U becomes an X, right? All the way through, every A is a 5, every U is an X. So it becomes X over 2, 25, because that's what 5 squared does, plus X squared, plus A squared, 25 over 2, natural log of X plus the square root of 25 plus X squared, add C. So the tables don't tell you the answer to this. What the tables do is they give you a guy who looks like him, but you have to do a little bit of tweaking, right? You have to adjust it. Typically, you have to know what A is. Sometimes they have an A and a B in it, you know, because it's, you know, AU plus B brackets, square root, you ugly guy, you know, something like that, in which case you have to recognise that maybe A is a 5 and B is a 4 and U is an X, for example, or a theta, whatever it might be. Are we good as far as that goes? Right. Now, this is question 1 from the homework, and it's the integral from 0 to 1 of the square root of x, take away x squared dx, and the entry, the one that you look for, is 113, okay? So let me show you how I would go about that question. So hopefully you're looking at the homework. There's question 1, you see it? And over here is the table. I should be able to do that. Now I am looking for, I know you can't see it anymore, but I'm looking for an x minus x squared kind of look, right? So you scroll through it and you're looking for the square root of some. Now, if you look at the beginning of them, they tell you the family. This next bunch are all going to have a square root of a squared plus u squared, right? So I don't want that one. If I scroll up the way, can you see I got some trig stuff going on, so I guess that's the wrong direction. I'll scroll down the way, and well, actually I know the number because they told me it is 113, so I guess I'll just scroll to it. But let's pretend I didn't know it was 113, right? Can you see that guy has got a something take away x squared kind of look to it? And so I am looking for the one that looks closest to mine, and can you see it's 113? Now I'm going to write down what that guy looks like, and then we're going to return back to my piece of paper. Take me a few minutes to write all this mess down. Okay, I'm ready. And this is what I have to work with. This is my question. This is what it looks like. So I need to figure out who is what, right? Would you agree that it makes sense that the U will just be replaced by an X? It's a little bit less obvious what's going on here. But essentially, don't I need to know what number A has to be? So 2AU becomes an X. Actually, 2AX becomes an X. So what fraction does A need to be for that to work?
1/2.
1/2. Because 2A is 1x, so A has to be a half. Now, I know A and I know that U gets turned into X's. This is the horrible answer that is next to 113. So instead of U take away A over 2, it becomes X take away a half over 2. Instead of 2AU, it becomes 2 times a half X, which guess what is X? Take away X squared. Oops. Don't want that. Plus A squared over 2, 1/2 squared over 2. Inverse cosine of 1/2 take away X over 1/2 add C. Do you see all the bits? Do you see that every A has been replaced by a half and every U has been replaced by an X? So far, so good. Do you think that is good style points? No. So you may well have to make it look a little bit prettier, right? That, for instance, would become an 1/8. If you multiply top and bottom by 2, you get a nicer looking guy. I don't really see much I can do with this fella. Is there anything you could do with this guy that might at least make that half go away? Any suggestions for what I could do to this guy to make the half go away? There's a chance. How about multiplying the top and bottom by 2? In what case I'd get 2x minus 1 over 4. Right, you agree that that looks much prettier than it did a few moments ago. That's just part of the style point world, right? Now, some questions have an extra step at the start. In these two questions, the guy you started with was the guy you used, right? But let's zoom backwards now and show you some more homework questions, because there's only 2 things I want to do, and this is one of them. Just make it a little bit bigger. Question 3. You will not find anybody who looks like 3 in the table of values. That's because about half the questions you need to do a U sub. What would be the U sub that you would use in question 3 that would get you the answers that you want? It's, think again, you're close, but not that. Oh, wait a minute. Did you say cos x or sin x?
Sin x.
You are correct. I don't know why I thought you said something else. Right. Let me zoom back and forward again. I wish it was just a little button I could press and say all this out and in, but never mind. Right. If you use sin x as your U sub, can you trust me that you end up with that guy? Do you know that guy will look like this guy in the tables? Now, I'm not going to go through it, take too long, but can I just pretend this is totally wrong, but made up, that the answer was a half u plus the natural log of u squared minus a squared, right? Just for argument's sake, let's say that's what the answer is, right? In this case here, wouldn't u be u and a would be 8? Agreed? So this would turn into 1/2 u plus the natural log of u squared, take away 64. But that's not the answer. Don't you have to return back to the x's? So if we were assuming that what I just said was correct, do you see that's what the answer would look like? So it does mean that you're going to have to do a U sub roughly in about half the questions to turn the guy that's no good into a guy that you can find in the tables. So that's the extra start step that some questions have. Not all of them, the other half go looking for it in the table right away. So that was one of the 2 things I want to do. Let's have a look at some more of those questions and I'll show you the last thing I want to cover from this section. So maybe I could make this a little bit bigger. Can I do that? Just a little bit bigger. Boom, boom. Yeah, that'll do. Maybe too big. There. Question 4 is good to go. It's in the tables. Just look for an a squared x squared plus b squared over u squared kind of guy, right? This one is good to go. Oh, not only is it good to go, they told you which one to use. This one is good to go. That one's the last thing I want to talk about. Here is one of the U subs. What U sub will you use in question 8?
Square root x.
Square root of x. And you just have to trust me on this because I'm not sure myself. The final answer ends up being 2 arctan u or a half arctan u. I'm not quite sure which one it is. I think it's a half, right? That guy you can find in the tables. In question 9, sorry. Look at question 9. Can you see that? I mean, it's kind of obvious, isn't it? It's a U sub. It couldn't possibly be in the tables, right? And if a really good choice of U sub, you are ready to rock and roll. So who is the U sub that's going to work in question 9?
Sin x.
Agreed? And that turns into a u to the 6 natural log of u, right? Actually, you could probably do that by integration by parts pretty quickly. But if you wanted to, you could go to the tables, right? There's no need to do a table if you can do it other ways, I guess. Question 10 doesn't even directly ask you to do it. It tells you one of these is the right answer, so I guess you do it in that sense. What it might not be so obvious is that it's a U sub, and it is a sneaky, sneaky U sub, not just a sneaky one, a double sneaky one. Who is the U sub in question 10?
E to the 3x.
Good choice, because it's the right one. Here's a harder question. Explain it to the others. Why? Could have been a luck, but I doubt it, right?
When you take e to the 3x and you take the derivative of it, you get the reciprocal times 1 over 3.
Right, so basic, yeah, if I can stop you there, because yeah. Aren't you basically, if I could shorthand what you're about to say, aren't you basically going to kill the e to the 3x off?
Yeah.
Right? And what you're saying about the reciprocal is totally true. I'm just stopping you because a lot of people are going to go, what? So if I just say it kills the e, the 3x off, they might be a little bit more comfortable, right? So that one turns into some version of 1 over, well, a third probably, over 17 minus u squared, and that you get in the tables. One of the cool things is, do you know if you do a u sub, won't your integral already have u's in it? So it might be a little bit easier for you to find it in the tables, because they all use u's. And if you're thinking about it, that's why they did it. Didn't they choose to use the variable u in their tables rather than the x's a lot, because that's a more likely circumstance where it would happen. Now, there's one, the last guy, and he's a long question, and I've just missed him, so where the heck is he? There he is number 7. And we're trying to find the integral from 0 to pi of cosine of 6th power of theta, d theta, but it could be x, it wouldn't really matter. This is not a u sub, although technically you could do it, but it would take you half an hour. You'd have to break it into a whole load of cosine squareds, convert them into versions of cosine 2x. That would get you versions of cosine squared 2x, which would then turn into versions of cos 4x, and you've lost it, right? You wouldn't want to do it, trust me. But the problem, when you go looking for cosine to the 6th u, which is fine, because that's pretty much what we're looking for, you won't see what you might be expecting to see. It's called a reduction formula. And darn it if I can find it, but I know it's here.
Number 74.
Thank you. Okay, I think I might have got my numbers all back to front. I did. There we go. Oh, you've already had to suffer this question, Kathy? Yeah, okay. So if you look at question 74, it's the integral of the nth power of u du, and the answer is 1 over n, the cosine to n minus 1 of u, sine u, plus n minus 1 over n, an integral of n minus 2 of u du. So let me leave this guy and show you what the problem is. Somehow I'm going to use this fella to answer this integral. Well, let's do the easy bit. Would you agree that n is 6 and u is theta? Right. So this fella, cosine of the 6th theta, d theta, becomes 1 over n, 1/6. The cosine of n take away 1, which means 5. So the 5th power of cosine, followed by a sine. Add that guy over that, that's 5 over 6. The integral of the cosine of the fourth power. If you're interested, do you know that they used integration by parts to get this formula? What about this fella? Don't I need to know what he's equal to get the final answer, right? The final answer can't have any more integrals in it, right? The integration has to go away. So how do I do that guy?
Use
The same
74
way.
again.
Yeah, but this time make n6, right? Actually, I can keep the theta if I like, but technically speaking, since I'm using this formula, it's a thing again. So what do I get?
Is it N4, not 6?
Well, welcome. So this guy is equal to all of that mess, so I don't have to write it again, plus 5, 6, put a big bracket around it. When you do a 4, you get 1/4 cos cubed sine plus 3/4 cos squared d theta, and to which I get this fella. 5, 6 times that guy is what? 5/24. So this guy. That times that, 3 and 3, 2, 2, 5, 12. 5/12, this guy. Now, do you see we have a cos squared left? Can you guess, some deja vu, how are we going to do this guy?
I don't think I agree with 5/12.
Oh, I could be counting wrong. 15/24. Right. How would you agree with that? Oh, wait a minute,
Go down to
15/24.
5/8.
5/8. Yeah, we'll settle on that. How are we going to do the cos squared? I can't count, as you already know, but 5/8. How do we do the cos squared?
We can use entry 64.
And we do n equals 2 and u equals theta. Can I just dot that, because you know you got the gist of it. Eventually you end up with an integral of 1, right, which gets you theta, and there'll be a multiple of it outside. Do we feel comfortable about how you're going to use these tables? Now, we are about to start a new section, a new chapter. This chapter chapter 8, deals with applications of integration. In other words, how you can use integration to find things. And the first one we're going to look at is we're going to use integration to find what's called arc length. So I'll give you an example of what arc length looks like. Oops. I curved a little bit more than I meant to, but that's fine. Can you pretend that it just made it? I would like to know what the length of that piece of string is, what the length of that arc is. So can you imagine a little ant here walking along the curve to here, and I'd like to know how many centimeters its journey was. Well, there is a formula for it, which you can go and look at the textbook, and it will prove it to you. And that's the formula when you are trying to find the arc length of a function called y equals f of x from x equals a to x equals b. Of course, you could have got a function that looked like this. Only this function would be called x equals, I know, g of y. You know, like x equals y squared, right? What do you think, based on the fact I've told you what this formula is, what do you think this thing looks like?
Replace x with y.
Okay, so integral from c to d, square root of 1 plus g dashed of y squared dy. So for all intents and purposes, can't you find the arc length if it's a function in terms of x or if it's a function in terms of y? Basically, don't you find the derivative of the function, square it and add 1, and stick it inside the square root, and the integral of that horrible mess is the guy you're looking for. Now, from our experience, square roots don't play well with integrals, right? Finding integrals with square roots, don't they tend to generate u subs or x subs? And that means 15 minutes a question. So there are, of course, going to be questions where that might well be the case. But let's show you some of the situations that happen when we find arc lengths. Sometimes that ends up being a number. In which case, won't you just add an x and evaluate? Right, so they're pretty easy to do. Sometimes the thing in the square root eventually becomes that. So you got to imagine something here plus 1 ends up being that, right? It's a perfect square, as we call it. When that happens, what can we do to simplify the integral if you're trying to find the square root of something squared? Well, let's make it more interesting. Let's make that 2x squared, just for argument's sake, right? What would you get?
2x squared plus 1.
Doesn't a square followed by a square root essentially cancel each other out? And sometimes it'll look like that guy, eventually. If that did happen, what technique do you think I should use to solve this question?
Table.
Actually, the tables will work. Will you control the urge to use tables until no other method works? Now, two reasons for that. The first one is just pure math. Actually, if the tables were really good, wouldn't we not bother to show you how to do any integral? We'd just say find it on the table, right? So that's one not very convincing reason. The second one is if you're doing, especially if you were doing a test, if you pick a table and it's the wrong guy, you're dead in the water as far as points go. But if you do the technique and you screw up, like I got a 2 and it should have been a half, won't you get most of the points because most of the working is there? So it's a safety valve to make sure that that happens. It's good math. Now, it doesn't mean that we won't use tables, but we kind of hold back on that until it's like nothing else works. So assuming that something else does work, which it does in this question, what technique would I use?
Trig substitution.
Good grief, you want to make yourself old before your time? Yes, trig substitution would work. Don't do it. Think easier.
U sub is the only thing left then.
Yes. Who is a U sub? Don't overthink it. It's an easy, it's a
4x
straight,
squared plus 1.
yes. 4x squared plus 1. God, you went and made that hard for yourself. You were going to go all sorts of places. Now, the poor soul who said x sub, yes, that would work. 20 minutes later, it would work. Would you get full points in a test? Of course you would. Would all the other mathematicians laugh at you? Yes, of course we would. But we're cruel that way. Are we good? Right. That would be the technique. Now, what other techniques? Numerical. In other words, use your calculator to get an approximate answer. You will know the questions of arc length that's going to happen, because they will say, use your calculator and give me the answer to 2 decimal places. Or they will at least say, give your answer to 2 decimal places. Hopefully they will say, use your calculator to remind you. Now, that would be, for instance, if I wanted to find the integral from, I don't know, 0 to 4 of the square root of x cubed plus sine squared x plus 1, right? Can you imagine some weird function and that's what I ended up with, right? Do you know there's not a u sub in the world that will save you? It's not in the tables. You couldn't do an integration by parts. You can't even do an x sub. That guy is dead. He is non-doable as an exact value. But you can get this guy on your calculator. Okay. So we have time. Let's show you. Some of you have got much better calculators than mine. And if you do, you should be able to find the menu. I'm going to see if I can remember where it is. But in my calculator, it's such an old calculator, it doesn't really matter. It's going to be math. I think it's 0 or something. Yeah, math 9. Now, I'm not using this because it's just a pain in the butt. But if some of you have got the real cool one, see when you hit that button, what you get is a lovely little picture that looks something like that. And you just fill in all the things and it's good, right? Are some of you smiling because you got a calculator that it does that? No, so you're stuck with a yucky one that I've got? Okay, so let's show you how I would do it. I could do it that way, but the syntax is so clunky that I always put a comma in the wrong place, or I forget the order I put things in, and I get frustrated because it keeps saying error. So this is a slower way, but at least it works. You type in the function. So it's the square root of x cubed plus, I need a bracket for sine x squared. Squared. There we go. Plus 1. And so hopefully I typed that guy in right. So this guy goes into your calculator as y1. I go to window and I go from 0 to 4. So I type in 0 and I type in 4. I then do zoom 0 so I can see what that curve looks like. They are always boring, nondescript curves, right? It's that guy. And so right now I've got this guy in my calculator from 0 to 4, which is what that curve is. Since I want the integral, isn't that the same thing as the area under the curve? So what you then do is you go second calc, and you choose option 7. And it's asking for the lower value, which is 0, hit enter. Asking for the upper value, which is 4, hit enter. And then you wait. Oh, actually, it's really quick. I was going to say you wait 2 minutes while it does it. And in this case, the answer is 14.37, let's say, if you wanted 2 decimal places. Does that make sense? That you can actually use your calculator in some situations, right? Are we good? Right. If none of those techniques work and you're ending up with a really ugly square root guy and you have to get an exact value, right? Because there's no 2 decimal place thing going on and it doesn't fit the sequence, then you go to the tables. So the tables is the last thing you ever do, not the first thing you do. Are we good? Right. So let's, we've got time for at least a couple. Let's pick a nice easy one just to get the story rolling. That's the function, which is basically a straight line. And I want to know what it would be from 0 to. So you can imagine it's x is 0, there's 2, right? You want to know that little piece of a straight line. I could do that all sorts of ways, but that's the question, right? Then the arc length is this fella, the integral from a to b, square root of 1 plus the derivative squared dx. In this case, do you see that it's a nice number? In fact, would it be reasonable to assume that if this is a straight line, won't they always be numbers? Right, any straight line will do, it would work. Now, to integrate a number, even a weird number, don't you just add an x and evaluate it, in this case, from 0 to 2? Then you plug in 2 for x, take away nothing, and there's your answer, 2 root 10. You like that question? Nice easy one just to get the storyline going. Now, while I get myself sort of a set up here, will you say hi to get attendance? No, let's do F, I think. Okay, is everybody who's going to say hi said hi? Okay, let's move on. Right, not a very weird function, but it's going to be a weird integral. Start with the function. This is typically the way I do these questions for the awkward ones. I actually find all the bits here, tidy it up, make it look pretty, and then once it's as pretty as it can be, then I go back here and stick it inside the square root. So in this case, would you agree that the derivative is that? Are you agreeing the derivative is that? Okay. Then we'll square it and add 1. So that's going to be 1 plus this guy squared, which is 1 plus 4x squared plus 8x plus 8x plus 16. So that's 4x squared, 16x plus 17. Which means that I can get the arc length now. It's the integral from a to b, 0 to 1, of the square root of 4x squared plus 16 plus 17 dx. How do you know that this isn't a tables question and it's a calculator question? Where was the clue in the question that made you know that you were going to use this guy?
Is it because there's two values with an x and one without one?
Not even that. Answer to 4 decimal places. If you are ever asked to find an arc length and they say to 4 decimal, to 2 decimal, to 6 decimals, you know it's going to be a calculator question. If that was missing, right, if it was just this question without that, then you would have to do an exact value answer. You are not allowed decimals, typically, unless they specifically ask for them. So if that was missing, you'd be right that this has got X's everywhere and there's, you know, that sounds like to me it should be a calculator, but the reason is because of this. If that was missing, I would have to figure out some darn way of getting the answer to that, which would probably be I'd have to look up the table and hope to God that there was a square root of an ax squared plus bx plus c in there somewhere, right? A generic quadratic, because that's the only way I could do it. I couldn't do it with any of the other, well, we don't have many techniques, right? Integration by parts, x subs and u subs, right? And none of them would work, I would believe. Okay, so I'll set the thing up, practice at getting this right. 4x squared, add 16x, add 17. The window is going to be from 0 to 1. Zoom 0 just to zoom to fit. I do that mostly because I want to make sure that it's, I haven't done anything weird. There's 7. Lower limit was 0. Upper limit was 1. And then wait. And to 4 decimal places, the answer would be 26.1234. So if you can imagine x squared plus 4x, what would that look like? It would look like that. And you did it from x equals 0, which is here, to x equals 1, which would be here. That little curve is 26.3333 units long.
I have a question.
Yes.
Did you remember to do you need to do the square root of the function?
Darn
I
it
got a
in
different answer as
space.
well.
Darn it in space. Did I forget the square root? It's in front of me, and I did. So square root of 4x squared plus 16x plus 17. Keep the window, do a zoom fit, so it'll be a slightly different curve, but it won't look much different. Looks almost linear. Do a second calc, choice 7, start at 0, finish at 1, and the correct answer is 5.1003. Are we good? Right. Get time for one quick, very quick question. Let's do it the other way. X equals y squared. And y is going to go from 0 to 1. I'd like to get the arc length. Well, it's the integral from c to d, square root of 1 plus the derivative of the function squared dy. It's integral from 0 to 1, the square root of 1 plus derivative is 2y squared. It's integral from 0 to 1, the square root of 1 plus 4y squared dy. Now, there was no mention in this question to 2 decimal places, so I can't use the calculator because that's what I would get. Can you trust me that this would not work with any kind of U sub you could imagine? And it's not an integration by parts, which pretty much it never is in these questions. So who am I left with?
X sub.
X sub. Or the tables. So here's me changing the rules. When you do this as homework, and it's ugly, I would use the tables. And when it's a test, do an X sub. That way I can give you more points. Right. Now, if you do an X sub, I guess I should call it a Y sub, but it's the same thing, agreed, algebraically. It will take you a long time, but you will get it correct, and that's what you're after. If you do a tables thing, you're probably going to have to look for some version of this guy. You may have to actually look for a U sub. You might think, I wonder what you're talking about. You might find that you need to do a U sub of 2y so that this turns into a 1 plus u squared du guy. I'm not sure if it's a half or 2, but whatever. And that's the guy that would actually be in the tables. So even that might not be in the tables. Now it might, I don't know what degree. If it was in the tables, you might get a, you know, that'll be a U there, won't you? You might get a guy that looks like that, in which case it works straight away, doesn't it? But if it didn't, you'd have to do some kind of U sub. So if someone, what am I at the bottom line? If something is not in the tables, but you know it has to be because there's no other choice, right? Because there's nothing else left, you may have to go hunting for some weird U subs, like 2y, to get it to a shape that allows you to use the tables.
Couldn't you also just factor out 4?
It would have exactly the same effect, so yes. Well, actually, you change that to a quarter, but you know, that's okay, because I bet you there's an a squared plus u squared in the tables, so you'd still be okay. Right. I asked my previous class